Hi guys, here's your video going over section 2.1, quadratic functions and models, and this is the lesson for day 1, where our goal is to change quadratic functions into standard form. So before we can do that, we first need to figure out what standard form even is. So if I look at this, I have two definitions of quadratic functions. I have f of x equals ax squared plus bx plus c. This one you typically use, or you typically see as your starting form, and then you can use the quadratic formula and so forth. For today, what we want to do is we want to get our original form of the quadratic function and change it into this form. So this form is called standard form. It is also called vertex form. And you'll hear me use those two phrases interchangeably, so vertex form and standard form. I like to call it vertex form because you can get your vertex just by looking at the equation. So my vertex is hk, so I have my h and my k. So our goal is to start from this original quadratic function to this one. That way we can start to identify a few things like the vertex, axis of symmetry, and x-intercept. So let's define those things as well. So we have important parts of the parabola, that's your axis of symmetry, x-intercepts, and your vertex. So if you look at this graph over here, you can see your parabola. Your parabola is a U-shaped graph from graphing your quadratic function. There's a couple important pieces. We have this point down here, your vertex. Your vertex is the max or the min of your curve. We also have these 2 points called the x-intercepts. They're also called the zeros of the function. It is wherever your graph crosses the x-axis. And we also have this thing called the line of symmetry or axis of symmetry, and that is an imaginary line going right through the vertex that creates a symmetrical figure. So if you notice, the right side of your parabola looks exactly like your left side. So our goal is to change it into vertex form and then find these three things from that form. So in order to do that, you're going to do a process called completing the square. So completing the square allows us to manipulate this function. So I'm going to go ahead and rewrite it. I'm going to write x squared plus 8x, and after my x term, I'm going to go ahead and insert a square, plus 7. And then since I added a square, I'm also going to subtract a square because we don't want to actually change the function, we just want to manipulate it into a different form. Now to figure out what goes in this square, I'm going to take this term, my x term, and I'm going to take that coefficient, cut it in half, and square it. So when I take half of 8 is 4, 4 squared is 16. So I'm going to go ahead and put 16 in both of these squares. Now these first three terms represent a perfect square trinomial because when you factor it, it's going to look like this. So I want to find two numbers that multiply to 16 and add to 8. Those are going to be 4 and 4. So I can write it like this, x plus 4 times another x plus 4. But another way that I can write it is just x plus 4 quantity squared. And that's the form that we want to use since that is what vertex form looks like. And then I'm going to combine the 7 and the 16, and that gives me -9. And now I have my function in standard or vertex form. Once it is in that form, I can go ahead and identify my vertex. Your vertex comes from these two numbers, h and k. So when you're doing the x-coordinate of your vertex, you're always going to take the opposite of what was in the parentheses. So instead of +4, I'm going to do -4. Y-coordinate is the number on the outside, and that sign does not change. So your vertex is -4, -9. Next thing I want to find is the axis of symmetry, which I like to abbreviate AOS. Axis of symmetry is a line, so it needs to have an equation. So that's going to be x equals, and then I'm going to go back and look at my vertex and find the x-coordinate of my vertex, which is -4. So my axis of symmetry is x equals -4. So far I've done these things. I found it in standard form, found the vertex and the axis of symmetry. The last thing I need to do is to find the x-intercepts. In order to do that, I'm going to take my equation, the equation that is in standard form, so the x plus 4 quantity squared minus 9, and I'm going to set it equal to 0. And the reason why I'm setting it equal to 0 is that your x-intercepts are where your graph crosses the x-axis, and that is when your y-coordinates are 0. That's also why they're called zeros, because you set them equal to 0. So now I'm going to solve this. I'm going to go ahead and add 9 to both sides. So I have x plus 4 quantity squared equals 9. I'm going to go ahead and square root. So I have x plus 4 equals plus or minus 3. Anytime you take the square root, you need to have a plus or minus. Now in order to get my two zeros, I'm going to go ahead and separate this into two equations. So I have x plus 4 equals positive 3, and x plus 4 equals negative 3. I'm going to go ahead and continue to solve both of those. My first x-intercept is at negative 1, and my second x-intercept is at negative 7. Now your x-intercepts do represent points, so they should be written as ordered pairs. So negative 1, 0, and negative 7, 0. And those are your two x-intercepts. All right, let's do another one. So for this one, I'm going to do the same thing. I'm going to start by rearranging it and inserting my squares. So x squared minus 10x plus a square plus 12 minus a square. And again, I'm going to focus on this term over here. I'm going to take half of it and square it. So when I take half of negative 10, that's negative 5. And when I take negative 5 and square it, that's going to give me 25. These three terms, I'm going to go ahead and factor. So I want to find two numbers that multiply to 25 and add to negative 10. That is going to be negative 5 and negative 5. So I'm going to write this as x minus 5 quantity squared. And I'm going to combine my outside numbers. 12 minus 25 gives me negative 13. So this right here is my function in standard or vertex form, which can allow me to identify the vertex. I'm going to take the opposite of what's in the parentheses, so that's 5 and negative 13. From there, I can identify my axis of symmetry, that's x equals, and I'm going to take my x-coordinate of the vertex, which was 5. And the last thing we want to do is to find the x-intercepts. And in order to do that, I'm going to take my equation in vertex form, and I'm going to set it equal to 0. So from here, I can add 13 to both sides. That gives me x minus 5 squared equals 13. To undo a square, I'm going to square root. That gives me x minus 5 equals plus or minus square root of 13. Now the square root of 13 is an irrational number, meaning that when you take the square root in the calculator, it gives you a non-repeating decimal. So preferably, I would like it if you left this as a radical. So I'm going to go ahead and proceed just like we did with the last example. I'm going to separate this into two equations. So x minus 5 equals square root of 13, and x minus 5 equals negative square root of 13. I'm going to add 5 so I can solve for x, and I get x equals 5 plus the square root of 13. I'm going to do the same thing over here, and I get x equals 5 minus the square root of 13. Now your x-intercepts, your x-coordinates look a little weird because you have both a radical and a number, but you're still going to write them as an ordered pair. So my x-coordinate is 5 plus root 13, y-coordinate's always 0, and then for this coordinate, x-coordinate is 5 minus root 13, y-coordinate is always 0. So there is your vertex, axis of symmetry, and your x-intercept for this particular problem. Now the two problems that we have done so far did not have any sort of number or symbol in front of your x squared. So now we're going to start to explore when that is the case. Okay, so if you look at this one, I have a negative in front of my x squared. That's the same thing as having a -1 there. Anytime you have a number in front of your x squared, the first thing you need to do is factor it out of your first two terms. Not all three, just your first two terms, the ones with the x's. So I'm going to take out a -1. And when I do that, I'm left with x squared plus 28x. And then I'm going to go ahead and insert my first square. Minus the 196. Minus, and then since I do have a number in front of my parenthesis, that same number is going to go in front of my second box. So that's one of the big differences between when you have a number in front of your x squared versus when you don't. That number in front of x squared is also going to go in front of your second square. From there, process is the same. I want to look at my middle term. I'm going to take half of it and square it. So half of 28 is 14. 14 squared is 196. I'm going to take this and factor it because that's my perfect square trinomial. So that's -1. I want to find two numbers that multiply to 196 and add to 28. That's 14 and 14. So I have x plus 14 quantity squared. And then over here, I'm going to go ahead and start to simplify. I had -196. Subtracting a negative is the same thing as plus. 1 times 196 is just 196. So that leaves me with 0. So this is my equation in standard or vertex form. My vertex is going to be -14, 0. And my axis of symmetry is x equals -14. Now again, to find my zeros, I'm going to take my equation in the standard form. So -1, x plus 14 squared plus 0, and set it equal to 0. Now I'm going to go ahead and solve this. I would subtract 0 from both sides. Well, 0 minus 0 is 0. I would get rid of this -1, so I'm going to divide both sides by -1. So I have x plus 14 squared equals 0 divided by -1 is 0. I'm going to go ahead and take the square root. Well, square root of 0 is 0. And then I'm going to solve for x. Now, usually when we take the square root, we have a plus or minus. That is not the case for this one because 0 is not positive and it is not negative. So I'm just going to write x equals -14, solving for that. So my x-intercept as an ordered pair is -14, 0. Now, if you look at what we have, compare your x-intercept to your vertex. They are the same. So anytime your vertex has a y-coordinate of 0, that's also going to end up being your x-intercept. So just a little fun fact for you. All right, last one. So again, I'm going to start by taking out the 3 from my first two terms. Not all three terms. Might be tempting to divide that 30 by 3 since 3 can go into it, but don't do it. Just take 3 out of your first 3 terms. I said that wrong. Take 3 out of your first 2 terms. Sorry. So when I take out a 3, I have 3x squared divided by 3 is x squared. 18x divided by 3 is 6x. And then I'm going to go ahead and insert my first square. Plus 30 minus, and then before I put my second square, I need to take the number that was in front of my parenthesis, and that is also going to go in front of your second square. And then to figure out what goes in the square, same thing, I'm going to look at this one. Don't look at this one, okay? You always want to look at the one after you've done the factoring. So I'm going to take half of 6 and square it. That gives me 9. So I'm going to put 9 in both of my squares. From there, I'm going to factor. So 2 numbers that multiply to 9 and add to 6, that's 3 and 3. So I have x plus 3 quantity squared. And over here, I have 30 minus 3 times 9 is 27. So 30 minus 27 is also 3. Lots of 3's for this particular problem. My vertex is going to be -3, +3. And my axis of symmetry, x equals -3. And then the last thing I want to do is I want to find my x-intercepts. So I'm going to take my equation and I'm going to set it equal to 0. So let's go through the process. I'm going to subtract 3 from both sides. That gives me 3 times x plus 3 quantity squared equals -3. I'm going to divide both sides by this 3. That gives me x plus 3 squared equals -1. And then from here, I'm going to take the square root. Well, square roots of negative numbers are not real numbers. They are imaginary. Square root of -1 is actually I. So when that's the case, anytime you're taking the square root of a negative number, your quadratic function is going to have no x-intercepts. So that is day 1 for 2.1.